Good day everyone, I'm Jenny Santos. I would like to discuss the solar power system. Solar power system is a conversion of energy from sunlight into electricity, either directly using photovoltaic or PV, indirectly using concentrated power, solar power, or a combination. Concentrated solar power system use lenses or mirror and solar tracking system to focus a large area of sunlight into a small beam. Photovoltaic cells convert lights into an electric current using the photovoltaic effect. This is the solar power at home. First is EcoSolargy solar panel. Collects sunlight and turns it into direct current electricity. Second is inverter. Convert DC current to AC current, which can be used to power appliances in your household. Third is electrical distribution panel. This panel feeds all of the household circuit. Fourth is AC loads. All household lights and appliances use alternating current electricity for power. And fifth, electric meter. The solar power system can generate more electricity than the household uses, causing the meter to spin backwards while feeding electricity back to the grid. The electricity bill will then be credited. And lastly is the main power grid. When the system generates power back to the grid, it can be used by someone else, helping to build a better tomorrow with renewable energy. That's it, the solar power at home. How to install. Next, we have four major components of solar energy system. We have a solar panel, inverter, batteries, and racking or mounting. First is solar panel. Solar panel provide electricity from sunlight. They are typically made of silicon crystal slice called cells, glass, a polymer backing, and aluminum framing. Solar panel can vary in types, size, shape, and color. In most cases, the size of PV module refer to the panel rated output wattage or electricity generating potential. Solar panel also have a voltage rating. Those with of 12 or 24 volts are generally preferred for off-grid system with battery backs. Other solar panels come in less common nominal voltage such as 18, 42, and even 60 volts. These modules are typically used in grid-tied application to accommodate the working of grid-tied inverters. Solar panels can be used alone or combined into array by wiring them in or in to achieve the needed. Next is inverter. Takes DC from batteries and turns it into AC, which is used to run most common electrical loads. Next is the batteries. Batteries chemical store electrical energy in renewable energy system. They come in several voltage, but the most common varieties are 6 volts and 12 volts. And we have 3 types of batteries. First is flooded lead acid batteries or FLA, and the second is sealed absorbed glass matte batteries or AGM. And ang third is seal gel cell batteries. Next is racking or mounting. Racking or mounting, this is what securely attaches your panels to the roof. Next is what is solar power and how does it work, diba? Sun is needed to shine down onto Mother Earth to help sustain the life of all the different types of animal and plants life that inhabit, as well as to grow our crops for food. But we can also use the radiant light energy from the sun to produce heat, light, and power in the form of electricity by using the sun solar energy. Yan. Ganun siya nag-work. Next is electromagnetic ray. Ano ba yung electromagnetic ray? In the form of radiant energy are being constantly emitted into space by the burning action of the sun. These rays travel through space in all directions while some reach the Earth's space. The radiant energy emitted by the sun reaches the Earth within a very short period of time. Next is solar power through the atmosphere. For example, gas and small dust particles suspended in the atmosphere will cause a scratching effect on the incoming solar radiation, resulting in some of being reflected back into space in all directions due to the air, clouds, rain, and haze. Clouds, which are made up of liquid and frozen water particles which scatter and reflect the solar radiation back into space, as we see on cloudy days. Next is solar radiation. Solar radiation is both scattered and reflected in all directions when passing through the atmosphere. These dispersions can be as much as 60% of the total value which reaches the Earth's atmosphere through space. Direct solar radiation, however, casts shadow because it is directional, coming directly from the sun. The position of the location of the sun in the sky also plays an important role in the efficiency of any solar power system. Next is photovoltaic solar cell. Solar power can also be thought of as solar electricity, and the key to solar power is the solar cell or photovoltaic or PV cell. Solar power is one of the most viable and cleanest form of renewable energy because we can use the sun energy within the sunlight to produce electricity by means of solar energy. The solar cell. The solar cell operates according to what is the photovoltaic effects, where photo means light and voltaic means electricity. Solar cells are more technically called photovoltaic solar cell or photovoltaic or simplify PVs. Photovoltaic are silicon semiconductor devices similar in many ways to electronic diodes and transistors. Photovoltaic produce electricity by converting the solar energy generated from the sun in the form of either visible light, ultraviolet radiation, or infrared radiation into a direct or DC current by using photovoltaic action of the cell without the use of any moving parts. Next is the type of photovoltaic cells. We have a monocrystalline silicon, polycrystalline silicon, and thin film solar cell. Monocrystalline silicon is a type of photovoltaic cell material manufactured from a single crystal silicon structure which is uniform in shape because the entire structure is grown from the same crystal. High purity silicon is melted in the crucible. Next is polycrystalline silicon, also known as multicrystalline silicon, is a cast to produce a silicon ingot. The silicon molecular structure consists of several smaller groups of grains of crystals, which introduce boundaries between them. Polycrystalline or PV cells are less energy efficient than the previous monocrystalline silicon BF cell because these boundaries restrict the flow of electrons through it by encouraging the negative electron to recombine with the positive holes, reducing the power output of the cell. And lastly, the thin film solar cell are another type of photovoltaic cell which were originally developed for space application with a better power to size and weight ratio compared to the previous crystalline silicon devices. Thin film photovoltaic are produced by printing or spraying a thin semiconductor layer of PV material onto a glass, metal, or plastic foil substrate. By applying these materials in thin layers, the overall thickness of each photovoltaic cell is sustainably smaller than an equivalent cut crystalline cell and hence the name thin film, as the PV material used in this type of photovoltaic cell are sprayed directly onto a glass or metal substrate. The manufacturing process is therefore faster or cheaper, making thin film PV technology more viable for use in home solar system, as the payback time is short.
Good day everyone, I'm Michelle Sican and I will be discussing semiconductor material used for a thin film type of photovoltaic cells. Photovoltaic panel convert light into electricity. Series connected photovoltaic panel, bypass diode protection, parallel connected photovoltaic panel, maximum solar cell power, and how to solve photovoltaic solar cell problems. First, semiconductor material used for a thin film types of photovoltaic cell include these three: cadmium telluride, amorphous silicon, copper indium diselenide. First, cadmium telluride. CDTE is a polycrystalline semiconductor material made from cadmium and tellurium. Thin film cadmium and telluride has a high light absorption level, so the amount of CDTE required can be quite minimal, with less than 1.0 microns of semiconductor material is needed to effectively absorb sunlight for the solar device to perform. Amorphous silicon, A-SI, non-crystalline form of silicon that is widely used in calculator, consumer electronic, and solar garden products that require small current at a low voltage. Of different types of photovoltaic cell available, amorphous silicon has a high Yes, light absorption of over 40 times higher than crystalline silicon. The advantage of this is much thinner layer of amorphous silicon material is required to make the thin films, PV cells, reducing the manufacturing cost and price. Third is the copper indium diselenide or CIS. Copper indium diselenide CIS is another type of polycrystalline semiconductor material composed of copper, indium, and selenium. CuInSe2. Thin film CIS types of photovoltaic cells can produce conversion efficiently of nearly 10%, almost double of that amorphous silicon without suffering from the same outdoor degradation problem due to their thicker films. Also, CIS cells are the one of the most light absorbent semiconductor compound absorbing up to 90% of the solar spectrum. Copper indium gallium diselenide, CIGS, is another type of photovoltaic cell. Is basically a P-type polycrystalline thin film material based on the previous copper indium diselenide CIS semiconductor material. The addition of the amount of the compound gallium or Ga produced the photovoltaic cell with a higher conversion efficiency of around 12% from the same amount of sunlight with an open circuit voltage of about 0.7 volts. Next, photovoltaic panel converts light into electricity. Photovoltaic cells use lights to generate electricity, and that there are number different types of photovoltaic cell technology available, including monocrystalline, polycrystalline, and thin film cells, which can be used to produce a photovoltaic panel. Electrical power in watts generated by these different photovoltaic cells, when exposed to directly sunlight, is true the same for each panel and is given as the product of the voltage times the current. P is equals to V multiplied by I. The amount of electrical power generated by individual photovoltaic cells at its output terminal depends upon the amount of the solar radiation that hits the PN junction, as well as the percentage of solar radiation it's actually convert into electricity. In other words, its efficiency. Series connected photovoltaic panel. Four photovoltaic cells are connected together in a series combination. If we assume that the output voltage produced by each individual PV cell in the chain of is 0.5 volts, then the combined output of the voltage will be the sum of the individual cell output voltage, and it is calculated as V1 plus V2 plus V3 plus V4 is equals the total of volts. Substituting 0.5 volts plus 0.5 volts plus 0.5 volts plus 0.5 volts is equals to 2.0 volts. For series connected cells, the combined output current is the same as the produced by each cells. Then I1 is equals to I2 is equals to I3 is equals to I4 is equals to I total. The combined power is the sum of the individual cell power or the product of the voltage times the current, as we seen previously. Next, bypass diode protection. The presence of the bypass diode limits the voltage across the bad cell. It is reverse biased to pass certain current. Bypass diode conduct, thereby allowing the current from the good solar cell to flow in the external circuit. The maximum reverse over the voltage across the bad cell is reduced about a single diode drop, so the larger voltage difference cannot arise in the reverse current direction across the cell, thus limiting the current, preventing overheating due to the less power is dissipated. Ideally, we would have bypass diode for each individual PV cells, but in practice, there would be one bypass diode for the number of cells. Parallel connected voltaic panel. For photovoltaic cell, solar cell are connected together in parallel combination. For parallel connected cells, the combination output voltage is the same as that produced by each cells. Then V1 is equals to V2 is equals to V3 and equals to V4. Maximum solar cell. We have this formula. P max is equals to V out multiplied by I max, where W is in watts, V is in volts, I in ampere. Problem number 1. Calculate the maximum output of a single 0.5D silicon photovoltaic cell with a maximum rated power output of 1.75 watts at a full sum using the formula Pmax is equals to V out multiplied by I max, given 1.75 watts and 0.5 volts. Solution: I max is equals to Pmax over V out. I max is equals to 1.75 watts over 0.5 volts. It's equals to 3.0 amps. Note that this is the maximum theoretical current, as the true or a real current is determined by the rate of incoming solar photons. The amount of electrical power generated by a photovoltaic cell depends on the solar irradiance and other conditions such as temperature and cloud cover. The power rating of the photovoltaic cell expressed in watts is the maximum or the peak power of the cell can be delivered at the full sun in the PV cell uncovered. Problem number 2. At the full sun, a 0.58 volt photovoltaic solar cell produced an output of 1.73 ampere. Calculated the maximum output of the photovoltaic cell in watts. Using formula P is equals to V out multiplied by I out, given 0.58 volts, 1.73 amperes. Solution: P is equals to V multiplied by I, 0.58 volts multiplied by 1.73 ampere is equals to 1.0 watts. That's all. Thank you.